Hi, my name is Mel. I'm going to do the very bare basics about databases. All right, this is just the very bare basics. So this is sort of people who are just entering IT or don't know much about it. So databases, so once you understand how the data is stored, organized, retrieved and protected, everything else becomes a bit easier to understand. And these basics will apply whether you're dealing with a relationship database like SQL or non-relationship database. Okay, so a database is a structured system for storing, organizing and retrieving data efficiently. So instead of saving information in random files, a database keeps everything organized so applications can find and update data quickly. So why do databases exist? They solve problems that simple files can't, like fast searching, handling thousands of millions of records, multiple users accessing data at once. They prevent, hopefully, data from being corrupted. Okay. Enforcing rules like no duplicate emails, backing up and restoring data. So the two types of databases are relationship databases, or SQL, structured query language, and NoSQL. So look, databases are the backbone of almost every app: banking, social media, games, business systems, websites, and so on. Okay, but so SQL, or relationship databases, or structured query language, uses tables, rows, columns like a super-powered spreadsheet. For example, SQL Server, MySQL, PostgreSQL, Oracle SQLite. Structured, so it's this key traits is structured, strict rules, uses structured query language, great for transactions and consistencies. Then you have NoSQL databases. So these are flexible, schemaless, and designed for massive scale. So examples can be MongoDB, documents, Redis, key value, Cassandra, wide column, and Neo4j is graph. So the key traits is flexible, high performance, and used in big data and modern apps. Okay, so it's basically that's just how they're structured is the difference between one type of database and the next. And so in an SQL, or relationship database, tables store data in rows and columns. For example, a user table. Rows, each row is one user, okay, or one record. So each row is one record, for example, one user. Columns, each column is a field. For example, name, email, password hash. Primary key, a unique identifier for each row. For example, user ID. Foreign key, links one table to another. So an orders table linking to a users table. Relationships, this is how tables connect. One to one, one to many, many to many. So common SQL queries that are commands to interact with the database. Select, which is read data, insert, add data, update, modify data, and delete, remove data. So then there's NoSQL. So document stores like MongoDB stores data in JSON-like documents. It's flexible structure. Fields can vary between documents. Key value stores, for example, Redis. Fast lookup using a key, great for caching. Wide column stores like Cassandra, designed for huge data sets across many servers. Graph databases, e.g., Neo4j, stores relationships as first-class data. Great for social networks recommendations. So how do databases store data? SQL databases store data in structured tables on a disk. It uses index to speed up searches. NoSQL databases store data in various flexible formats such as JSON documents, key value pairs, graphs, column families. Indexes. Indexes are like indexing a book, speeding up searches. Without an index, a database scans every row, With an index, it should jump straight to the matching data. Indexes improve read speed but slows down writes slightly. Okay, so this is just sort of going over some of the basic terminology you'll hear with databases now. So transactions. A transaction is a group of operations that must all succeed or all fail. Like, for example, deduct money from one account, add money to another. If anything goes wrong, the database rolls back to a safe state. This is the ACID model, which is A for atomicity, consistency for C, isolation for I, and durability for D. Backups and recovery. Databases include tools to backup data, restore from backups, replicate data to other servers, and fall over during outages. This is why databases are used for all critical systems. And security basics. How do you protect data? So that's authentication, who can log in, authorization, what can they do, encryption, data protection, auditing, tracking changes. And the principle of least privilege access is essential. Only give users the access they absolutely need. All right, so look, databases are built from structured storage, fast retrieval, relationships, rules and constraints, security, backups, and scalability. All right, and this is just the very, very bare basics. All right, thank you for your time.